Welcome back to The Explainer. Today we are diving headfirst into a really fascinating journey, the rapidly evolving world of fintech and investment management. We're going to explore exactly how the intersection of finance and advanced tech is honestly completely transforming how investment professionals evaluate opportunities, optimize their portfolios, and mitigate risks. It's a massive shift in the industry, and you know what? It all starts with the data.
Think about this for a second. It's kind of wild, right? How do we actually take a million random tweets, or literally satellite images of parking lots, and turn that into a profitable investment strategy? Keep that provocative question in the back of your mind as we go through this explainer. The modern world has produced an absolute explosion of chaotic, unstructured data. It's a massive problem of scale and complexity, but as you'll see, it's a problem that comes with a pretty heroic technological solution.
So, here is our roadmap for today. We're going to start broad with the big data explosion, then look at tapping alternative data, pop the hood on the machine learning engine, and finally, wrap up with data science in action. Let's jump right in.
All right, Section 1, the big data explosion. Let's talk about the sheer, overwhelming scale of modern information.
For decades, financial data basically meant traditional corporate reports, regulatory filings, sales figures, standard stock exchange prices. But since the late 90s, the definition of big data has grown to mean these vast, almost incomprehensible amounts of information generated every single second. We're talking data from industries, governments, individuals, and an ever-expanding network of electronic devices. It is an absolute avalanche of new information. It's chaotic, it's messy, and it is massive. And we usually define this avalanche by what we call the 3 Vs. First up, volume. We are way past megabytes here. We are scaling all the way up to petabytes of information. Second is velocity. The speed of data has moved from these periodic, slow batches to continuous, near real-time, and even real-time streams. And third, variety. Data just isn't sitting neatly in structured rows and columns anymore. It has exploded out into unstructured formats. Think photos, social media posts, mobile video, the whole shebang.
But here's the catch. When we actually try to use big data to make solid investment predictions, an absolutely crucial fourth V comes into play: veracity. Veracity is all about the credibility and the reliability of those data sources. Confirming the veracity of this totally chaotic data is, honestly, a huge challenge for financial analysts. You have to ask yourself, does this data set have selection bias? Are there missing values? Big data really just amplifies that age-old challenge. How do we disentangle actual quality from sheer quantity?
Which brings us to Section 2, tapping alternative data. So how exactly do we categorize this wild frontier of non-traditional info?
Well, as investors look way beyond those traditional financial statements to find their edge, this alternative data cleanly falls into 3 main buckets: data generated by individuals, by business processes, and by sensors. Let's make this tangible, okay? For individuals, we are looking at unstructured stuff like social media posts, web searches, online product reviews. For business processes, think of what we call corporate exhaust. Things like retail point-of-sale scanner data or credit card transaction flows. That gives analysts a real-time read on how a company is doing way before quarterly earnings are ever released. And for sensors, man, this is where it gets incredibly futuristic. Analysts are literally using satellite imagery of retail parking lots or shipping cargo to predict economic activity. They're even tapping into the Internet of Things, gathering data from smart buildings that report on everything from climate control to energy consumption.
But all that raw material is totally useless without a refinery. Let's move to Section 3, the machine learning engine.
We hear this buzzword all the time, right? But let's actually demystify it. Machine learning, or ML, simply involves computer algorithms that extract knowledge from massive data sets without us having to make prior assumptions about the underlying probabilities. The algorithm generalizes from known examples, so it isn't explicitly programmed with rigid step-by-step rules by a human. Instead, its entire goal is basically to find the pattern and apply the pattern to make future predictions. Broadly speaking, we divide these techniques into 2 main camps based on how they're trained. In supervised learning, both the inputs and the target outputs are labeled. You're training the algorithm to predict a known target, like, say, predicting if a stock return will go up or down based on historical examples. But in unsupervised learning, the computer gets completely unlabeled data. There are no predefined targets at all. The algorithm's job is simply to find the underlying structure completely on its own. For example, discovering entirely unexpected peer groups among companies based on shared characteristics, rather than grouping them by traditional industry sectors. And pushing the very boundaries of this is deep learning.
Deep learning utilizes neural networks, which is essentially computer programming inspired by how the human brain actually learns. These networks process information through many hidden, complex layers, allowing for multi-stage, nonlinear analysis. This layered approach is exactly what allows modern computers to achieve such crazy high accuracy in advanced tasks like image, pattern, and speech recognition.
But as with anything, there are pitfalls. A super common trap for analysts is finding the right balance between overfitting and underfitting. Overfitting happens when a model learns the historical data way too precisely. It essentially memorizes the past, treating random noise as a true, permanent rule. So an overfitted model looks absolutely perfect in testing, but fails miserably in reality with new data. Underfitting is the exact opposite. The model is just too simplistic and misses the true underlying patterns completely, treating actual facts like random noise. Getting this balance just right, that is the true art of the data scientist.
All right, bringing it home with Section 4, Data Science in Action. Let's zoom in to see exactly how investment professionals deploy these tools on a daily basis.
When you're dealing with big data, you obviously can't just open a spreadsheet. Data scientists follow a really strict pipeline. It starts with capture, collecting the data with minimal delay, which is absolutely critical for algorithmic trading. Then comes curation. And guys, I cannot emphasize this enough. Curation is vital. This is the cleaning phase where errors and missing values get fixed because bad data guarantees bad investment decisions. Next up is storage, navigating whether to use traditional databases or specialized ones for unstructured text. Then search, to efficiently query these massive archives. And finally, transfer, moving that precise data right into the actual analytical tool.
And one of the absolute most powerful analytical tools they transfer that data into is natural language processing, or NLP. NLP is a specific application of text analytics that uses insights into the structure of human language to analyze text and voice. It is basically the ultimate tool for unstructured data. I mean, think about it. Globally, corporations generate tens of thousands of hours of earnings calls and literally millions of pages of reports every year. No human could ever read all of that. But NLP? It can turn all of those hours and pages into actionable, summarized intelligence in a matter of seconds.
Okay, let's anchor this back to investment reality. Financial analysts might officially change their buy or sell rating on a stock very rarely, but their written reports often contain nuanced, subtle shifts in tone well before an official downgrade actually happens. An NLP algorithm can literally read between the lines of thousands of analyst reports, assigning sentiment ratings from very negative to very positive. It can even scan the transcripts of the Federal Reserve to detect waning or trending topics, allowing investors to predict interest rate policy shifts before they even hit the news. So, how do we humans process what the NLP algorithm finds? Often through data visualization techniques like a tag cloud. You know, you can't exactly plot unstructured text on a standard line graph, right? So a tag cloud physically scales a word based on its frequency in the data file. If a central bank suddenly starts using the word inflation much more frequently, it visually pops right out on the screen, immediately highlighting key themes for the portfolio manager. Which leaves us looking at a truly fascinating horizon. We've seen how big data has just exploded, how we capture alternative sources, and how machine learning engines like NLP process all of it. But as these algorithms learn to read between the lines, perhaps even better and faster than we can, what will be the true value of human intuition in the future of investing? It's pretty clear that the future belongs not to the algorithm alone, but to the analyst who knows exactly how to guide it. Thank you so much for joining me on this explainer, and hey, keep questioning the data around you.